So the things we are going to go through in this lecture or in this segment we are doing is introduction about Black Scholes, then Black Scholes option pricing model, what it really is and what are its formulas and how to assess it. In the next step, we will be calculating an example of a Microsoft stock option in which we will be calculating Black Scholes prices from historical data. Using the Black Scholes then we will use then you will use Black Scholes to solve the put premium to call put parity. So let's start with our lecture. First of all, what is Black Scholes? Black Scholes option pricing model, or BCOPM, is one of the most important development in finance in the last 50 years. Why? Because it accurately predicts the options price beforehand. So we will get the good understanding that what price the option should be sell or buy. When option was created, it was more attractive to individual and institution as well as both. So it is a key component because it hedges our risk against stocks, and it is a very key component. So let's start with Black Scholes option pricing model. We will discuss what the model really is, what are the development and assumptions of the model. Then we'll go to determinants of the option premium. What are the determinants that change the call option or put option premium? Then the assumptions that we take while calculating the Black Scholes model, and in the end, the intuitions into the Black Scholes model. So what model really is? It is a formula that calculates that what premium is accurate or what premium is necessary to get to pay for the option. So this is a formula S n of d1 minus k e power minus rt n d2, where d1 is natural log of s divided by k plus r sigma square divided by 2 into t, and whole divided by sigma into under root of or square root of t. D2 is also has a similar formula, but to make it easy, we just do d1 minus sigma under root of or square root of t. So now we'll define the variables. What are these variables that we have just gone through in the formula of option pricing? S is the current stock price. K is the option strike price. So if you look at the formula, it is almost like the formula of forward pricing, where we discussed the forward price, and there we use its formula to assume to get the answer. So it's a little bit similar, but there are some differences because stock uses stock. We assume that stock is a natural. It has a natural graph, and that's why we use nominal graph, and we will discuss that later. So S is the current price, K is the option strike price, E is the natural base log because we assume that stocks follow the natural logarithm route. Next, there is R, which is the risk-free interest rate or risk-less interest rate. So we take that uh, to devalue or to take the strike price to the present value of the stock, because we have to assume that what is the strike price, what would be strike price at the present value. That why we that's why we compound the stock to a rate which is risk-free interest rate, because we assume there is no risk in buying the option. T is the time until the option expiration, and sigma is the standard deviation of the returns of the underlying security. But we assume that the stock will go through some standard deviation, and we have to take them into account, and that why That is why in the D1 and D2 we take the account of that stocks standard deviation. ln, as we all know, is a natural logarithm. ND1 and ND2 are the cumulative standard deviations of the function. So we assume that the stocks will follow the normal distribution curve. As I have discussed before, the stock will follow the normal distribution curve. So in the normal distribution curve, the stocks will uh, first go up like a normal distribution curve, and then it will reach the highest point, and then it will go down, and again it will reach the lowest curve, and then it will move up. So if we see any stock and we shrink its time to a point, to a certain point, every stock will have a certain normal distribution curve. So that is why we assume that stocks will remain in the normal distribution form till the option is availed. So by taking the assumption, we will talk about this assumption in the later part, but I'm just going through that right now. So let's go through the development and assumptions of the model. How did this model was developed? This was developed from the physics, as we use Brownian motion to describe the stock prices. That Brownian motion shows that it has no regular pattern, or its pattern is around the normal distribution. So we say that, or we also use the heat transfer motion is also used from the physics to derive the formula of black holes. The next is mathematical shortcuts, as we use integration in the formula, because this formula is a derived formula which I have just discussed with you. The formula was derived with the help of integration and natural distribution functions, and in the end natural log function. So we use all of these uh, integration, derivation, natural log functions, and normal distribution functions to calculate this formula. So mathematical shortcuts were used to derive the formula which we have now. And arbitrage argument. There is an arbitrage argument that we use to develop the formula. These are, these are the names of the persons who basically created the Black Scholes model, and it was named after them. Fisher Black and Myron Scholes utilized the physics heat transfer equation. So they use the heat transfer equation basically to start their formula for a Black Scholes model, and then they use the mathematical shortcuts and arbitrage argument to reach a point where it is now a certain small formula which we can conveniently use to calculate the call option or option premium. Determinants of option premium. There are few determinants of option premium which we will discuss right now, and then we will discuss how these determinants affect the option premium. So striking price is 1, time until expiration is 2, stock price is 3, volatility of the stock is 4, dividends is 5, and risk-free interest rate is 6. So how stock price affect the call option? So the lower the striking price for a given stock, the more option would be worth. How is that? Because if the strike, as from the formula, we can clearly see that if the strike price lowers, the option will be worth more, because we actually minus the present value of the strike price from the stock price. So if it is lowered, the stock will be the option will be worth more. And because call option lets you buy at a predetermined striking price, so agar, so if the strike price is lowered to a point that it is convenient for us to buy the strike at a lower price, we have to give the high premium, because we are availing a lower strike price right now, and for that we have to give more premium. Time until expiration, the longer the time until expiration, because then the stock will be going through some changes and there will be a risk factor involved. So the longer the time, the option will be worth more. And it is clearly from the explanation, we can clearly say that it is, and from the formula, we can also derive that. Now, next is the stock price. Greater the stock price, greater will be the call option worth. it is higher right now. So the call option holder will benefit from the rise prices, and that we assume that greater the strike price, greater will be the call option premium. And it is also stated that from the formula that greater the stock price, because we minus it from the current value of or present value of strike price. So greater the stock price, greater will be the call option, eliminating the other factors remaining constant. Volatility to sigma. Greater the price volatility, more the option will be, but it is clear from the statement that if the stock is more volatile, that means that its price will change accordingly, and there will be a risk factor involved. So if someone is giving you an option to buy that stock at a certain price, fixed price, while it is more volatile, that means he is taking a lot of risk, and for that risk, he will need a hedging premium, and that premium is called premium. So uh, it is volatility play a major role in determining the time value of the strike price. Dividends. If a company pays a large dividend with a smaller option, then the company will with a lower dividend. That means that uh, uh, if a companies pay larger dividends, then their premium will be smaller. And if the company pays lower premium, it will be a call option will be higher. So we haven't discussed how dividend affects, because we are assuming that no dividend, cash dividend is paid during the time of the call option premium. So we will discuss that later on. Risk-free interest rate. Higher the risk-free interest rate, higher the premium. It is so simple, because if the risk-free interest rate is higher, we have to compensate that in the premium of the option. So that is as simple as that. Now we will discuss the assumption. Stock pays no dividend during the option's life. As you can see from the formula that we haven't calculated any dividend to fee or any dividend. So that means that there we don't talk about dividend right now. The first Black Scholes model didn't talk about the dividends, but later on there are some changes in the formula. We discuss about the dividends and options. The second is we only use European exercise style. That means that we are only talking about European call options or European put options. Not we're not talking about American option, because American option gives us a lot of time, because there is no bound time maturity. So a European has a fixed time maturity, whereas American option does not have any time limit. So we can cash in the option at any time. So it is a little difficult to calculate the American option. Is third assumption is market are efficient and everyone knows the information, and market just adjusts itself to the information very quickly. So there are three to four theories regarding the market efficiency, that the weak market there are weak markets, there are semi-strong markets, and there are strong markets. But we are not going to discuss them right now. But in Black Scholes, we majorly assume that markets are efficient. Fourth one is there is no transaction cost. We assume there is no transaction cost. While we'll know that there is a transaction cost while buying or selling of options, and we eliminate that in Black Scholes. And many people actually eliminate the transaction cost, and they calculate the value of the stock or the value of the option without the transaction cost, which sometimes causes the losses to the person. Now the fourth one, which we use in every almost every model of evaluations, whether they are for stocks or whether they are for bonds or whether they are for options, is that interest rate remains constant. So we assume that during the time of the call option, the interest rate will remain constant. And the last one is prices are log normally distributed. So this means that we assume that the prices of the stocks are log normally distributed, like they follow the log normal curve. But actually, we know that yeah, to some point we actually see that, because if we shrink down the time of the stocks prices, if we shrink down the price stock to a certain point, they are normally distributed cars. So as we have discussed that no dividend is used, Robert Martin actually uses the formula for no dividend. So Robert Miller option pricing model uses these formulas. He added, if you can see in D1, he added R minus D. So this shows that R minus D shows that he has added a dividend in the formula. So we have talked about that European style and American style is more valuable than European because it gives you few option of exercise early due dates to time value. We see that it gives us option that we can avail the American option at this point or at this point or at this point. So we have a few other options then. Market are efficient as we have talked about that people predict but bullish or bearish trend regardless of the premium. No transaction guard. Then we have asked that there is no commission or bid or ask price spread or difference, which is not true in any condition. Interest rate again. Interest rate we use the T bills for the risk-free interest rate, but there can be a change in interest rate because of any different. So integrations into the black hole. The value of valuation of black hole has two parts. One is the cash inflow that we will get, and the other will be the cash outflow that we have to give. So one gives the positive probability of the weightage expected stock price. So stock price actually discuss with us the cash inflow, that how what will we get, and the other will that the time adjusted or what we call this compounding of the strike price. So the payment we actually have to give. So we can see that CSND1 means there's a stock price and its normal log is cash inflow, while minus in the strike price and its present value to the normal log. Normal distribution shows the cash outflow. The value of call option, as we all know, is discussing. Now we will discuss the example of the black hole from the historical data. We will use a real life example where Microsoft had a call option at the price of 70, and at that Microsoft actually price was strike price was 70, and the stock price is 70.75. Maturity time is 58 days. Its volatility is T bills is at 6.1, which is 0.061, and its standard deviation is 0.5671. So sigma is 0.5671. Now using the black hole, we will first calculate D1. As we all know, stock price is 70.75 and strike price is 70. We actually put them in the formula. We can also use Excel for this. We can also use financial calculator for this to calculate the D1. After calculating D1, we will calculate D2 from a simple formula, which is this, and we will calculate D2, which is minus 0.029. Next, we will go to using the normal probability table, or we can use Excel for this, and similarly we can use financial calculator for this, and we calculate n minus d n function of d1, which we will get minus 0.5805. You can also calculate this right now from your financial calculator or Excel, or from the normal distribution table, probability distribution table, which you can access from your books. Next is next we just put these values and we will get $7.04, $7.04. So this means that this option is valued at this option is premium is valued at $0.04. So if we have to buy an option, it means that we can buy this at the $0.04. So this is about call option. Now we will discuss how put option is calculated. So put option is almost similar, but as it is a put option, so we use put call parity to discuss its formula, which comes as P strike price, its present value, and normal distribution, and minus. As you can see, it is from the buyer's perspective. So we use the strike price first, and then the stock price, because we minus the strike price present value from we minus the stock price value from the strike price's present value. So these are the all for today. I think it is enough. We will discuss how to calculate. We will discuss how to calculate actually from Python, the present value, the actual call premium of the stocks in the next video. Thank you all.